Good day. I am Strelia M. Rosete from BSIT 2A. This time, we are going to discuss about tree data structure. When we say tree data structures, it is a hierarchical structure that is used to represent and organize data in a way that it is easy to navigate and search. So as an introduction to tree, a tree is a finite non-empty set of elements. When we say finite non-empty set of elements, it is a set containing one or more elements. So next, it is an abstract model of a hierarchical structure. When we say hierarchical structure, it has an arrangement. So next, it consists of nodes with a parent-child relationship. And three also is best applications to organizational charts. For example of this organizational chart is the employees and positions for best suits in companies, schools, then system which files are named and where they are placed logically for storage and retrieval. And programming environments is a collection of tools used in the development of software. So when we send a tree viewed as a nature view of a tree, it has branches, leaves, and the roots. Roots usually at the bottom, but in computer scientist view, roots here is at the top. Then it has also branches, its nodes, and leaves. So here are the three terminologies. When we say root, node without parents, here in the illustration, root here is the A. Next is the siblings. Siblings, nodes share the same parent. Here in this illustration, siblings are the B, C, and the D. Internal node. When we say internal node, node with at least one child. So here in this illustration, A, B, C, and F are the internal node. Next is the external node or the leaf. Node without children. So in this illustration, node without children are the E, the I, the J, the key, the J, the H, and the D. Next is the ancestors of a node. When we say ancestors, they are the parent, the grandparent, the grand-grandparent, and etc. So self-explanatory. So next one is the descendants. When we say descendant of a node, they are the child, the grandchildren, the grand-grandchildren. In this illustration, ancestors are the B, for example, is B, and the descendants of the descendant of B are the E, the F, the I, the J, and the K. Next is the depth of a node. When we say depth of a node, they are the number of ancestors. Height of a tree. Height of a tree has a maximum depth of any node, which is 3 in this illustration. Degree of a node, the number of its children. The degree of a tree is the maximum number of its nodes. Then subtree. tree consisting of a node and its descendants. So here, this is the subtree here in this illustration. Then age, connecting lines of a tree. So tree terminology, when we say number of nodes, its value based on the diagram is 9. So bakit siya naging 9 is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the height based on this illustration is 4. Then the root node is the A. Its leaves are the D, the H, the I, the F, and the C. So when we say interior nodes, based on this illustration, interior nodes are A, the B, the E, and the G. The ancestors of H in this illustration are the G, the E, the B, and the letter A. So the descendants, how about the descendants of B? When we say descendants of B, they are the D, the F, the E, the G, the H, and the I. So who are the siblings of E? E. The siblings of E are the letter D and the F. Then the right subtree of A is the letter C. Right. And the left is B. So when we say degree of this tree is the number 3, which represents the total number of a node. So there are types of tree. They are the general tree, the binary tree, the binary search tree, the AVL tree, and the splay tree. They are the 5 types of tree. When we say general tree, if no constraints or rule is placed on the tree's hierarchy, a tree is called a general tree. Every node may have infinite numbers of children in general tree. So the tree is the superset of all other trees. Next one is the binary tree. When we say the binary tree is the kind of tree in which most 2 children can be found for each parent. So the kids are known as the left kid and the right kid. Another types of tree is the binary search tree or the BST. It is a binary tree extension with several optional restrictions. The left child value of a node should in BST be less than or equal to the parent value. And the right child value should always be greater than or equal to the parent's value. The fourth one is the AVL tree. AVL tree is a binary search tree self-balancing. On behalf of the inventors, Adelson, Velshi, and Landis, the name AVL is given. So AVL is Adelson, Velshi, and Landis. That's the meaning of the AVL. So which was the first tree that balanced dynamically? A balancing factor is allocated for each node in the AVL tree based on whether the tree is balancing or not. So the height of the node kids is at most 1, AVL vine. In the AVL tree, the correct balance factor is 1, 0, and -1. So if the tree has a new node, it will be rotated to ensure that it is balanced. It will then be rotated. So the fifth one is the splay tree. When we say splay tree. It is a self-balancing tree, the same with eval tree. That makes the splay tree unique in the extra property which is splaying. So a splay tree contains the same operation as a binary tree, binary search tree rather, through its insertion, deletion, and searching. But it also contains one or more operation. Example is the splaying. So all the operations in the splay tree are followed by splaying. So to elaborate more on the binary tree, a binary tree is a tree with the following properties. First, each internal node has at most 2 children or the degree of 2. Next property is the children of a node are an ordered pair. So next is binary tree also call the children of an internal node left child and right child. Then alternative recursive definition of a binary tree is either a tree consisting of a single node or a tree whose root has an ordered pair of children, each of which is a binary. So binary applications are used in arithmetic expressions, decision processes, and for searching. So when we say binary tree traversal, a tree traversal is a specific order in which to trace the nodes of a tree. And this binary tree traversal has 3 common tree traversals. First is in order, second is pre-order, and the post-order is the third one. When we say in order, it moves left to root, then right. It prints it must be prints each subtree's left branch before we print its roots. So note that pre and post refer to when we visit the root. So when we say pre-order, it prints from the root, then to left, then to right, as well as for post order, which moves from left to right, then to root. Here is the example of binary tree traversal. Based on this illustration, when we say in order, which prints from left root to right is 3. 3, which is located at the left side. So 3, 5, then 6, 7, 10, 12, 13. Then papunta din siya sa root, which is 15. Then 16, going to right, 16, 18, 20, and 23. So for printing as pre-order, which moves from root left to right, is from root, which is the 15, then to 5, going to left, which is 5, then 3. Then print the 12 to 10 to 6 to 7, then the 13. Then going to the right, which is the 16, 20, 18, and 23. They are the printed in pre-order binary tree traversal. Then Let's go to the third one, which is the post order, which moves from left, right to root. So here, the left one is the 3, going to 7, then to 6, then to 10, then going to 13, then 12, then 5, then 18, 23, 20, then 16, then the root, which is the last one, is the 15. So let's exercise. Printed in order. So, which moves from the left to root, then the right. So 1, 3, 4, 6, 7, then the root is 8, then 10, then 13, and print 14. Next one is in pre-order from root to left, then right. So root is 8, then 3, then 1, then 6, 4, and 7, then 10, 14, and 13. The post order, which moves from left, right, then root, is R1, 4, 7, 6, and 3, then 13, 14, 10, and 8. 8, which is on the last, which is the root. Then another binary tree traversal exercise. So moves in order. In order here, from left, root, and right, then left is 5, 10, 12, then 20, 22, then 25, 28, 30, 36, then 38, 40, 48. Pre-order moves printed from root to left, then right. Where is the root? 25. Here is the root, 25. Then move to 20, 10, 5, and 12. Then 22, then 36, 30, 28, then 40, 38, and 48. The post order here, based on this illustration, from left to right to root, are 5, 12, then 10, then 22, then 20, then 28, 30, then 38, 48, 40, then 36, and the last one, the root is 25. So let's have a recap with the three terminology. When we say question number 1, when we say maximum depth of any node, it is what? It is height. Then number 2, when we say child, grandchild, grandchildren, or etc., it is a descendant. Yes. So next is nodes share the same parent. It is a siblings. Yes. Number 4 is the maximum number of its node called a degree. The number 5 question, it is a lines connecting of a tree. It is an edge. Then It is a node without parent, or the A called the root. Yes. Then when we say node with at least one child, it is internal node. Then another one, a node without children, it is external node. Then a parent, a grandparent, grandparent, or etc., it is ancestors. Yes. Then question number 10, the number of ancestors, it is addict. Then the number of each children, it is a degree of a node. Then the last one, when we say tree consisting of a node and its descendants, it is a subtree. So this ends with my topic. Hoping marami kayong natututunan sa video na to. Then thank you for watching. God bless.